Good morning. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India. On this day, May 31st, 2021, last day of May. Topic of today's talk, as usual, is regarding civil field engineering, impact of COVID-19 on engineering and relevant designs, construction methods, contracts, organizations, communications, coordination, quality, and etc. And major it is issue of quality, which is prime top. You can see this certificate here, that is professional engineer certificate or international professional engineer certificate. Then it is chartered engineer certificate. Then it is fellow membership of Institution of Engineers India certificate. Purpose of these certificates is to show to you that many people, thousands and thousands professionals have certificate everywhere and everywhere, but still quality is waiting to be welcomed. It's not welcome, unfortunately. Quality says, I am not your guest. You don't care for me. Why? A question arises. And that question is very, very difficult to be responded to, at least by me. Because I never even viewed to 20% of works be qualified. No, not even 20%, not even 10%, not even 5%. That's the reason I say quality is required everywhere. Otherwise, I would have said quality exists everywhere. Quality exists everywhere, which I never said because I did not find it anywhere. And that is what is my point, to project you quality. Very easy to say, very easy to claim that this is quality work. This work is unequal. Everybody can say, even a person who does not have any knowledge of quality. You can say a person who got no interest in quality, but that person can also guarantee you for purpose of sales, yes, I can say that this is best one, this is quality one. You will not find this type of product anywhere else. I have heard this from many mouths. And what to do, you can only hear. But when I don't get this through professionals, really, it brings disappointment to me. Professionals are very qualified. Our engineering professionals, and in particular civil engineering professionals, who are very, very educated, having many, many degrees. Some of them claim they are structural engineers. Some of them claim they are soil or rock mechanics experts. Some of them say, means there are so many expertise, I cannot name everyone. I have this expertise, I have that expertise. Very fine. Congratulations to all of you having certain expertise in a period of 2 to 3 years of your education or post-graduation. And you think that this 2 to 3 years education gives you expertise. That's very good, nice. So you have got expertise through certificates. But have you ever thought yourself that expertise which you got in, is that expertise introduced into products you deliver? That's my point of view. And it's a blanket statement, it's not individual statement. I am not too young. I have seen life now. I have seen decades in profession. Here and somewhere else in various countries. It doesn't mean that I am a world person, means I am an ordinary person, having ordinary opinion, having ordinary thinking mind. But even if it's ordinary, it is good one, because an ordinary mind can look better than very specialist minds, because sometimes it happens that a specialist doesn't think for other specialization. Specialist thinks only for its own field. This happens. But specialists forget that whoever specialist you are, ultimately you have to deliver something in physical form. Design specialist, planning specialist, or you can say in retrofitting specialist, or you can say whatever field is there. In civil engineering there are designs, there are construction issues, and there you can say estimation people, there are, you can say, quality people. There are so many classification people, engineering people, all are there. And of course there should be. How can you work without that? But I can say that specialization of construction, or rather I should say highest level of profession, if you can see in profession itself, how highest level of specialization lies in production, because production is a concentration point, it's a convergence point where designs, planning, methods, theories, you can say codes, procurement, whatever activities are defined elsewhere in other specializations converge into construction, and construction results, construction projects, construction products announce automatically what is our standard. Really, if you want to see standards of profession, you have to study constructed product, and you shall know what people actually do. And that's very important point. If someone wants to see evidence of quality, it's best you go to sub-site and see how structure is constructed, how it is produced, before finishes apply on those structures. That is an only way, at least, to understand quality. You will not understand quality in totality until you go through all test results, all structural working documents, but you can see in view at least what sort of quality it is. You will, I am sure, be disappointed in majority of cases, not even majority, you can say 95% of cases, you shall be disappointed. And that is very responsible statement I am making here. I understand that it is very easy to say, this is not my specialization, I am a design engineer, why should I worry about construction? Same way procurement guy can say, and also estimation guy can say, quantity guy can say, or even then somebody else can say, why should I worry about that? I am not paid for that. This means construction has been related, or profession has been related to payment. What payment I am getting, I have to think of that. This means our soul has been linked to payment issue. If I am not paid for, why should I worry about that? Very great question. Very good answer. I am not paid for this. Why should I worry about that? So this is what I can say. Profession has been reduced to something unknown, or you can say something substandard quality. Quality itself, it was very common when I was too young. Just got educated and just got job. Of course, not having that level of expertise, but quality was respected by everybody. to some extent, I can say, though not there was no system like there was no formal system like we have today. It may be organization of ISO, or it may be Sigma, or it may be something else. Those types of professional, managed, organized organizations and systems did not exist in those days, but work system existed. Usually, specification was, you can say, equivalent name of quality. Quality was linked to production of specification, compliance to specification. Though it was enough for quality, means if you have to produce quality, whatever has been specified and whatever has been required on designs, you have to produce that. There was some confusion in this. Some used quality or testing or workmanship or design. These had certain, you can say, confusing relations, while in fact all should be given total title of quality, because quality is not only in works execution, quality should be everywhere. And fact was that work was done manually, designs were done manually, drawings were done manually, so there was enough chances for professionals to at least know everything. Means it was not that leave it to draftsman or leave it to someone junior designer and let him take care of every design and detailing. I will just go through when design drawing is given to me or final software file is forwarded to me. I'll go through that folder and see what design he has done. And you remember, when you do not involve yourself in detailed designs, you may forget something. This happens. So I'm not going to criticize that, but ultimately product that is to be done on site, that is to be prosecuted on site of construction, should be clearly defined. It should be speaking detail. Like we say, speaking means it should be clear in each and every respect. If there is some question to those designs, those drawings, answer should come clearly. And if I don't get answer clearly, I cannot expect site professionals or semi-professional, para-professionals to get answer rightly. We should not forget, ultimately it goes to some those types of hands who never ever studied, just know how to do it. And they may not even know constructability problem at time of viewing those drawings or reading those drawings, but when they meet problem on site at actual location, they will start saying, what is this? It can't be done. What designer did? Ask him this question and that question. And it would take some time for communication of that information, clarification, and then after getting clarification, you will have a lapse of many days. So that is a question here. Means it is, see, we should not undervalue construction and designs. Both are linked together. You may say architect gives birth to architectural drawing. You may say architectural drawings are brainchild of architect, whereas structural detailing being brainchild of structural engineer or civil engineer. And then total product on site is related to all professionals and all others who stay on site and work. It's very important. We have to understand. No one person's responsibility. Designer expects that site person should take care of everything, and that is expectation, and site person should do that to maximum extent possible. While you can say site person expects that designer should give me every details in clear terms and must not miss anything, any detailing which is required for site, because both are overloaded. If you look in normal situations, Normal situation means when project runs, there is time limit. Every limit is there. Pressure from owner exists, pressure from engineer exists, pressure from contractor exists. Goal of everybody should be that this project should be constructed and delivered in good shape, in good time, in contract time, and there should be no problem. That is actually total issue, I can say. If it happens, it's great. We should recognize that. But does it happen? That is question mark. And if it doesn't happen, why it doesn't happen? What is problem lying behind that? We have to understand that. We have to analyze this lapse. This lapse. Why this lapse happens? Why, first of all, job is job, project is project. Project is silent. We construct that based on designs and this is delivered. But don't forget, project is silent, but virtually it speaks. It speaks in terms of its physical attainment, how it is delivered, what additional points it is enriched with, and what you can say deficient point it is broken with. It is unspecified work, substandard work. Both points exist. You can view on a project just even on walking, while walking on road. Oh, you can say this project has some problems. I can't see this column in plumb, or I can see distress in that portion. I can see honeycombing in that in the concrete, or I can see voids in that concrete, or you say these joints are not clear, these joints are not cold, these joints are cold, and you can say there seems to be no surface arrangements. Still, so many defects you can see even from distance, though you have got no relation to that project. But project announces to people what I have been given. I have not been given my food properly. I have not been given my medicine properly. I have not been taken care of. This is what that structure announces. And that announcement is very important. And that announcement says, I had some requirement to be fulfilled. And none of these professionals, none of these contractor parties, none of these owner, no one stakeholder has cared for me, but they own right of calling stakeholder on my behalf. I can't help it. I can't give in writing. I am just here sitting like a monument, and nobody cared for me, and nobody shall care for me. This is just, you can say, hypothetical statement, but this remains factual one. Shape of project, view of project can tell you what is its quality, and that quality in designs can be taken care of very easily. I can say designer is very intellectual person. That's why one is designer. Everybody cannot be designer, even you are a graduate or postgraduate or a doctor in engineering. Designer must have certain instinct, must have certain, you can say, internal power to contemplate, to think, and to design and to produce detailing, which is very significant power, significant sequence of activities for design. Sometimes simplicity in design is very important. Sometimes designs are so complex that nobody wants to read those drawings. And same applies to specifications. You know that designers generally do not specify. I don't know reason. Specifications are made standards. Oh, we have a standard specification. We have general specification. It's written, so we need not worry about that. We will just copy and paste. And nobody even reviews what was written before and what was done in the field. Was there any change, or were any questions were raised, or some other deficient quality it led to? Means all those points, you can say, we should come in form of lessons learned from field or never learned. Everybody keeps eyes closed and they just sit drying and do job. That's it. Don't worry. Okay, specifications are there. We are following specifications, and they say we are following specifications. And by chance, if you have an opportunity to talk to some engineer or some supervisor, can you tell me what specifications did you follow? That person, so we followed what's given in our scope or in our time. No, tell me what actually you did. Then you will not find satisfactory answer. You will find hooping answer. That answer which can never be coordinated, never be linked together. Supervisors or foremen or general foremen or those site engineer who regulate work, who do work on site. I'm saying regulate because after all there is some regulation instructions. Instructions are given and work is done. It's a kind of regulatory mechanism that work on site, which is based on designs and detailings as well as specifications. I still remember my time when I was a first job, and I too was of same, you can say, dirty status. Means I did not even know. I just never got interest, and nobody instructed me to take interest. And I still remember that instance. It was in 1975 or 74, 75. In 1975, I was supervising construction of a shopping center in Delhi, in Ashok Vihar area. I was engineer to supervise that project, and one contractor. Of course, all contracts work there. What happened when superintendent engineer visited site, and he visited and got, and then by chance why he was leaving site after visit. There was no problem on site, but just he asked me one question because I was too young. Maybe he wanted to test me. He asked me, "Did you read a specification? What specification you are following?" I was so innocent. I said, "No, I'm not read. I'm not read." So he was laughing. What are you saying? You did not read specifications, and you are supervising this job. I said, yes. I don't know specification. I was very angry. You don't know specification? I don't. I know specification book. Okay, you go today, read the specification, ask your senior to get you a book, and then you come to me in evening in my office and tell me what you have studied. Well, I was really like a student. I was upset. Means what this senior engineer has commented on me. Then I asked my senior, immediate senior, this happened. He was laughing. Get me book, I have to reply to him. He said, okay, if I give you specification, then you hope, and I hope, that you will stop work. And these people never wanted to stop work, even if work doesn't meet requirements. So that example I am referring to you, quoting to you, because this is fact of life. General understanding in engineering was that a successful engineer means work should be done. This is successful engineer definition. If you stop work, you are a failed engineer. This was told by many people at that time, that engineer should keep project working, construction working, otherwise you are a failure. I was surprised really, but what to do? There are so many specifications in every government department, and who has time to read them? Because when we could not read properly during college time, just read only limited syllabus to pass examination, how do you expect that in field we would read all those two specifications? I have not seen people reading such specifications. I have not seen that. And contracting community know it very well, and also knew at that time. And they used to clearly say, oh, you people are engineers, What do you know? Sometimes they go buttering also. Oh, you know too much, Raj. There are such engineers who know nothing about anything. Yes, they will keep you happy also. And I was very young, not matured enough to understand what is a responsibility. Well, there's no use in beating about past. Question arises, now what is my friend quality that requires? I should consider quality as my friend, as my guide, as my director, or you say, as my destiny. If I achieve quality, well, I think I should be happy that I achieved some requirement. And I think it takes some initiative. And I have seen and I have observed that if you do not do quality work, you're not going to save something, you're not going to make more profit. If you are going to do bad quality work, you may have to face losses, though we think that we have done well and we have got well, but you can hide quality, you can hide bad quality indeed. It is very easy that I can say I have concealed this quality by finishing items. We can say that, oh, I'll put plaster on that. The journalists, don't worry, I'll put plaster. Oh my God, you want to hide quality? But you did not save anything and you are spending more money on plaster or on finishes or on something else. I have seen people, you see, there's honeycombing on concrete surface, columns, even columns. Forget slab, forget beams, columns. Main element of taking load and movements, and even at bottom of column, in middle of column, at top of column, on sides of beam. I know you can find plenty of honeycombing surfaces, plenty of wires, such that people did not care at all while pouring concrete or while working on formwork. You will find many cases like steel bars are exposed, but they don't care for everything. Their simple way they used to do, and still many do today, make some mortar and put on that to hide, and then gunny bag is there, just put impression of gunny bag on that while concrete or while metal is wet. This is beauty of our hiding, and I think people are so habitual, they neither care and nobody objects. They don't object because I think they compromise with this. They compromise in a way, oh, if I point out this, this shall go to everybody and they will say this engineer did not supervise properly, and contractor wants that state. That engineer should not say anything, because contractor also know that all are sailing in same boat. Nobody wants bad name. Of course, I know contractor is also not going to save anything on behalf, but progress is an issue. They want to move further. They want to move project at cost of quality loss. But you see, you want to do your project, you want to deliver this, and engineer wants to supervise it and close it and say, okay, it is completed. But ultimately, who suffers? My friend, project suffers, RCC suffers, concrete suffers, and those who suffer, who will buy it or use it, means you are giving something wrong to them, and you are feeling happy. So you know how long it shall suffer. It shall suffer throughout life of project. So maybe you reduce life, or say you did not do right work and there is fire break out, it will impact on that. Or you did not do curing well, it will impact forever. So there are so many ways. Sometimes I ask people, you are not worried about curing, and you just say, means just put some water on that and say, okay, it is done, nobody is going to ask us. Fortunately, structures don't collapse regularly, that's also true. It's not because of they don't want to collapse. There is safety factor everywhere. We take stresses in percentages, limited percentages. We never apply concrete stress to full, concrete load to full, the full resistance of that concrete section. We never apply force that steel bar can take. So there is ways means to abuse that safety cover. That safety cover is not for such purpose to abuse in quality production. That cover is different. There are so many reasons for that with no use of talking here. But that abuse of safety cover, safety stresses are abused by both by contracting persons and by engineering supervisors. And owners don't understand that until they themselves are engineers, but also owners when they are engineers, they do not remain engineers. They become business people. So for them, I think this doesn't mean anything. I am not young engineer, and I should not say that I am very senior, but what I have seen here, particularly, I can say in my country, India, Bharat, I'm not talking of all other countries. There are some countries too, you can say, I should not name them, I have seen, and there are some countries which are brilliant in qualification, brilliant in, you can say, in quality, that no one can beat them. And there are some which are like us, and they don't care. But I say we are a nation of very thoughtful engineers, brilliant experts. We have experts, I think now, if you survey, you will find that more than 70% engineers who come after passing first degree, that is bachelor degree, you can say all generally 70%, more than 70% generally go to post graduation degree. And this is, I can say, post graduation is very common now. It was not in my time. I never thought of post graduation because I was too busy on sites, and I thought to do that, but I could never get an opportunity because we had to find jobs also. I tried to learn a lot on projects, but these people, they think, I understand, these people who have plenty of degrees, MTech, ME, PhD, particularly young, I can say, I'm not talking of veterans, these people think this is everything in life. And moreover, they're all computer oriented, which means they have no input to calculation world. They depend on somebody else, and that somebody else's software. It is still fortunate that supervision and prosecution of works are done by people themselves. We can use computer for support, but we can't use computer that you go and construct this. Computers can't construct. They may surveillance, but surveillance is different. Surveillance cannot give you quality. So what happens, I understand now. If you understand yourself, you analyze yourself, why people are interested in office work, and that too in designs. Because designs have become very, very, you can say, easy in a way that calculations you are not going to do. Formulas are still available. You have to just do feedback of your requirement, data feedback. To be very frank, you know how to use software, what is the software, what are formulas. Main point remains that decision making on coordinates, decision making of loading informations. You have to feed all them if you know them too, and you will get results. So actually it is data entry, technical data entry, you may say, engineering data entry. So what happens? You get results, and you try various loads, and you get various results, and that's your qualification. Because there are so many calculations, so many formulas, so many equations you might have learned, but real learning comes when you apply them, and it's software that applies. So what happened? you will find some degree of comfort. Of course, work is overloaded because of software and immediate results to get, and you have to try. But fact remains that you are not experienced to real thinking. You are experienced to thinking of getting results and comparing them. You don't know how to get results in first ab initio, you can say, what we used to call first principles, and first principles have gone away. Now world has changed. Structural work has changed. Structural engineering has changed. Advancement has come. But advancement is useful only, it's workable only when we are advanced, when our minds are advanced. Why you will find so many structural engineers claimer? I see everybody says I am a structural engineer. Okay, you are welcome. No problem, you are a structural engineer. But do you know structural engineering? That's my point. What do you mean by structural engineering? That's also my point. Do you really know total definition of structural? That's my point. They think design is a structural engineering, which I don't agree with. Yes, it is a structural engineering, but this is not exclusive. That's my point. Structural engineering is design plus structural production. That is my understanding. Maybe I am wrong. Maybe you can say I am wrong, but I don't accept that I am wrong, because design is important, very important point, very responsible point, very much professional work. But what is purpose of design? Purpose of design is that this work should be done practically, physically, mechanically, given shape according to this design. That is important requirement. That is important destiny. If my design does not get it, people do not do this. I mean, those people who are responsible for construction, they do not have seriousness in their minds to produce or to realize design into construction, and they do their way. Design of structures, and I say others, must be qualitative and reliable. Where are? And also that designer, that engineer of designs who was responsible for that field, that work, that project, that must know what happened to this, or somebody else in that place should have responsibility towards it. But if that there's no responsibility, somebody else take responsibility, where is responsibility then? Where is accountability then? So I can say structural design is one part of structural engineering, while structural construction is another part of structural engineering. Structural construction is always very difficult because it is not easy. It's not plaster, it's not flooring, it's not roofing, it's not fixing a lath for plaster. It's different. It requires complete technical knowledge. It requires detailed specifications, applications. This is complete technical job. You cannot say that it is construction alone, and should not take it that way. Every structural engineer on site, I call them structural engineers who deal with construction of structures. They are also structural engineers of construction for construction. If they do right, I think design is called implemented. And if these people do not do right work, and whole design is design, standard design, quality design, only up to detailing, not beyond that. So destination of objective of design is not achieved. It remains incomplete. It remains only in files, in papers, not in reality. Until construction is done in compliance with designs and the specification requirements, you cannot say this construction is professional. I would not call that a structural professional building or professional structure, that is incomplete in construction, that's incomplete in design application, design real application, and that is on site. So for me, that person is also design or a structural engineer, because you have to think a lot while working on structural construction. You need not think that much on finishing items. You need not that much on other items, development items. You need think a lot while doing construction, because it is first body, it is first work that allows all other works to sit on this, to rest on this. If a structure is excellent, if not excellent, you can say admissible, it's okay, fine, good, we can use it, it's a durable one, it is having expected level of quality input, we can say okay, all other items coming onto this internally as well as externally would survive and would do better. That's what we should think. So all site engineers, I can say, all project engineers, I can say, all quality engineers, I can say, all planning engineers, I can say, those who work on projects, they are indirectly to some extent design engineers or structural engineers, because designing and keeping stresses within limits, and you can say monitoring all designs yourself and deciding, adjudicating your designs, also there applies to how to do it. Basically, it's great thinking that's required, that it should be efficient work, it should be right work, it should be compliant work, it should be, you can say, quality work. People should say what work he has done. Then they will say, okay, best designer who designed this, and best person who did this on site. So compliments come to first, what best design it is, if it is best. People see, they look at projects from distance also, and they see, oh great it is, oh see, there is a problem, steel bar is seen, or this is wide, or this is what these are. They can't name correctly, but they point out in different way, and they will start blaming engineers. Oh, this engineer knows nothing, like that. So what I am saying is, that's why I try to stress on quality of professional classes, professional sections, design section, work section, and all other sections, engineering section, quality section. Quality is very important. People say this person is quality person, and you talk to that person, you will find that there is no quality in that person. Really, sometimes I find people like that, and they prefer to come in capacity of quality engineers. Well, there was no quality engineers in my time, but I'll find those people, and quality people, they are named quality engineer, quality manager, quality inspector. Yes, they are indeed. I had many chances to talk to such professionals. Of course, if one says I'm quality inspector, I'm quality engineer, then in first instance, while welcoming that person, I have to respect. I have to pay my regards to that person, thinking that person is expert in quality. But when you come closer in knowledge to that person, you will find that, in fact, I'm sorry to say, that person, of course, qualified, but to an extent quality is concerned, is fake. You talk about quality, you won't get any answer. Yes, they would say, I would inspect this, I would examine this, I would check out what is this, and they they do not go beyond prescribed format. There's format for everything, format for checklist, format for inspection and test plans. That they know. Means quality, somebody says, I'm quality experienced, I'm quality qualified, I have this training, I have that training, they will show you so many certificates. But they do not tell these certificates are not for quality control, these certificates are quality system. They are in fact quality system engineer, quality system inspector, quality system manager, and not quality manager. They will be very upset with me, I know. I least bother because I have experienced it. System is something else. Technicality is another point. It's very easy to write system statement, very easy to say what we have to do, common sense says, but implementation of that, control of that is very important. I have seen such quality engineers who are arrogant. They say, no, it's not my job, I'm not site engineer. You do it, fill form and give me, I'll check. It's right or wrong. It's accepted or rejected. I've seen such quality engineers. And not one, not two, generally all. Means a sentiment in them, a kind of, you can say, ego in them. I'm quality guy and I have to just check it, examine it, and that's it. I'm not concerned with something else. And if you do not do it according to what is required or what I say or what they say, then I will reject it. I'll produce non-compliance report or non-compliance. I'll put in non-compliance, non-conformance, you can say, NCR, non-compliance or non-conformance reporting. This means it's kind of police work. You are not working in quality, you are working in police, site police. While objective of work should be that we have to deliver best quality. Now you have power that you can reject something. But you have also a duty. Maybe site engineer is not very experienced, that doesn't know, but is qualified as well. You too must be qualified. But I have seen that generally they are not engineering graduates, they are rather science people somewhere, and they are given some training. By virtue of experience, they know something. I did not find, except at management level of quality, that they are, well educated, professionally educated. So I'm not here to discuss qualification of those or qualification of site engineers. My purpose is, my objective is, quality must be achieved. Structural designs must be qualitative and reliable, and structural prosecution on sites must be competent and must be done consistently. There should be no lapse, no gap, and by chance if some error is caused, this must be discovered and corrected. Means quality is beyond limit. If we achieve that only which is prescribed by specifications, I think that's enough. I'm not saying go to skies and bring quality. Nobody can do it because it says all stages designs, but only design does not suffice. We say all stages design from initiation of some project to completion of that project. I am saying all stages designs, but only designs do not suffice, or only design handling does not suffice. If construction and development are not affected to mark, design drawings must have quality and duly coordinated details. keeping abreast site working conditions. This point is very important. If we have powerful design, indicative design, commanding design, I think site guy would be happy to read such design, to study such design and do job based on that, because it gives pleasure. If it is speaking design, it gives answers to all requirements, and that too qualitatively. So you see, first of all, that person who is going to work on site becomes tension free. Okay, I have all information, I'll be ready. And that person either does it self or give that drawing to some related person who starts working on that. That's one part. Means coordination in that case is not a big problem, because part of design coordination had been taken care of by designer, whereas site worker, site structural engineer, who is there to work on that from point of view of prosecution, does it. So site working conditions can be better only if we have clear conception of what we are going to do. No hodgepodge, no imagination, and no consideration. Of course, industrial practice is a must. Manufacturer's instructions we have to follow, which site engineer and design engineers both must know this fact. No imagination, because work you are doing are paid, work contractor is doing is paid, and all payment is done by work by person who is a stakeholder, prime stakeholder, and that is owner of that project. So we can say construction based on reasonable coordinated quality design is a big requirement, which says that all activities must be taken care of, but it doesn't happen. It doesn't happen. How to see this happen? How to, you can say, recover our status in quality which we have lost. We have lost quality not because we can lose, but it's only because we never try to understand it. We never try to understand it. There was a thought in some time only tests are done and quality is done. If tests are successful, quality is done. That's okay. Material testing is one part. That test means quality control, and that is material testing. I'm not talking of quality control alone. I'm talking of quality, which is quality understanding, which is systems quality, which is material quality, which is work quality, which is, you can say, application quality, and you can say which is quality that covers every requirement, every part, every related specification. All should be in compliance, if not 100%, to some tolerable percent. That's what I want to say. For that purpose, we should know how to do work. Okay, I'm not going to designs because they are very intelligent people. They are cream of profession, and they should know what to design, how to design. But I do not take into my consideration those who are just new, because they have to learn first for a couple of years, and that learning should come from sites rather than from air-conditioned offices. Because if you have to learn something, you must know problems in that first. If somebody has an objective to become structural designer, I best recommend that one should have some experience on site. Means what problems do you see on site, because nobody would tell you what are problems in fields until you go and find yourself. But they will not accept this, I know, because once you have certificates, you have some kind of ego in you. Oh, I have this certificate, I have that certificate, and that's what I am. So that certificate, you can say, provides an offensive thinking, an offensive smelling in your mind, and that's where problem lies in. Engineering is not dependent only on academic qualification. It depends on your working, style, your working power, your, you can say, pickable power, how packable you are. It depends. You are packable or not packable. You are work oriented or no. You can go to whatever extent to be aggressive as far as production and quality are concerned, or you can say quantity and quality are concerned. Very important point, because every day in construction is important, every hour in construction is important. Time cannot be wasted, and that can be done only when you know what to do in advance. And that's why we say look ahead program, or we say that, you can say planning. I say planning, you have to look ahead how to organize your work. That's reason and that's requirement that we prepare schedules for designs, schedules for construction, schedule or schedule, I can say in other language. This schedule, or this, you can say, bar chart, previously used to be critical path methods, or you can say PERT, program evaluation and review technique. We used to work within those techniques, but ultimately simplest is bar chart or Gantt chart, you can say Gantt chart. That gives you complete input, and that input should be related to our, you can say, our intelligence, our proactive arrangement. And proaction is very important here. Proaction is actually start of engineering. In fact, proaction not in size, proaction everywhere. And civil engineer or structural engineer must be proactive. Proactive means don't wait for some command, start. You command yourself. Yeah, of course, if you have clearance of that project, I'm not saying otherwise. You command yourself, you move yourself. Maybe you find some problem in beginning, but there may be one problem or two problem or three problems. Everything cannot be a problem. So you try to solve that problem and then keep moving. If you keep moving as engineer, I think all others shall keep moving. That's required. So don't worry about anything. First you check yourself in quality. Where do you stand? But I say that there's a quality approach for construction method, statements, requirements, and which says expression of details in convenient format for whatever work you do. And that's what I say, expression of details, expression of deliberations. You can say, if you have deliberations, if you conduct deliberations for something and you record that on some professional document, that's important so that everybody can know that. Expression of details in convenient format for work, performance, and define, elaborate performance. Of course, if you are proactive, time shall be proactive with you. Time always works with you. It doesn't stop until you stop. If you don't work, you try to, okay, we'll see later on. Time cannot see later on, time shall go away. Keep waiting. Time doesn't care for you, for me, for everybody. So we have to understand that if you want to value time, we have to value our proaction. We have to do, no worries about, you should not go to an objective, I have to get this information. You start yourself. So time is very important, which affects cost also. And you can say both are dependent on each other. And I explained many times about risks and reliability. That risk, if you don't have complete details, if you do not know what I have to do, and project is running, at that time it runs. So you can't hold project also. And you are discovering details which you don't have, or some other problem you're not solution. That you can say it's called risk. Time loss risk, or money loss risk, or project progress loss risk. Such kinds of risks also called risks. And such point of instability, you can say, Means that's called without homework we open project, without doing basics works we open project, and those terms available cause problems. Now we have to understand so many points in engineering and definitions of all these. As I again say, reliability of actions is very important. Being engineer, if you are not reliable, if I'm not reliable, and we have to define reliability means there should be safety factor in our work, there should be service factor in our work, there should be long distance travel factor in our work. Means building or structure is not going to finish in 2 or 3 years after its delivery. It has to stay for decades and for centuries. That point we have to keep in mind. That point means if it is long distance travel, you must have adequate input of quality of travel, and that is very important point. And design is analytical based, also construction is practically analytical based, if you understand that. Of course thinking applies everywhere, I don't say no. Now I'll come back to quality after some time. Let's go to now our talk that is we are making that talk about you can say we are here for quality requirements, which is basics of our talk and very important. I will spend just considerable time in explaining what is design and what is site work. For me, as an engineer, both are important, both are significant. I like to do both, and I have done both in my career. I don't claim that I am a design engineer, and I also don't claim that I am a site engineer. In fact, I am a person who can say is an ordinary one, layman or lay person. Because there's nothing, if I put myself, I'm a structural engineer and I'm a construction engineer, I would say, okay, let people say, I don't care about this. If I'm desire to design, if I have work of design, I'll start that. If I have work of execution, I start that. Yes, there are procedures and there are systems that to do it, but I won't mind it. Even if I have to do quantity work, I do that. Or if I have to do, writing work, I do that. It's pleasure. Coordination, I have been coordinator. Total coordinator I have been. Total means coordination of everything. I've done, project planning also, scheduling. So I can say I know nothing, to be very frankly speaking, I know nothing. And that statement is very powerful, because when you do nothing and you speak and you do something, it's very, very crucial. When problems are not solved, those reach coordinator. That's the important point. I had some formats, or you can say supportive formats of quality inspections, or not for quality inspectors, for site engineer itself. Means I'm claiming that we have to work for quality, but we have to understand what is quality. That's what I explained. But how to achieve is also important. This means engineers should know first what works are involved in structure of this project, every structure of this project. And structure is not simple one structure. Project has got many structures, and structural elements, both are there, both are important, both are significant. So engineers should know first indicatively what actions are required within certain work or certain part of a work, component of work. So first we have to do some, you can say, policy, you can say planning on that. Means it's not actual planning, but you can say it is prime planning, or you can say it is a kind of specification planning that you are writing. You go to write to your working specifications, not technical specifications, how to get this objective. And for that person, for the persons, I have some records of quality check, because what you have to check, you should know first. You should know what you check, and if you know that, you can write yourself what points I have in mind and I have to do for this. And you should do only when you get job, that's true, but you should know requirement, what requirements are. That's important. So in this case, I have put many methods, or you can say many checking methods, or you can say checking sequence, checking list. It is checklist for various items, and I have gone through. For example, this is setting out and excavation item. Then it should be, you can say, check list of hand excavation, and of course then it is formation, means where you have to start work, and also it is build blinding concrete. Then it is, can say, waterproofing or concrete protection, how to protect concrete from impact of soil and something else, the water. And you can say foundation, footings, preparatory works. And preparatory works are, reinforcement and shutters, form. And also you can say columns, small columns or stub columns, which are embedded in soil. Then backfill activity, and of course it is grade slab, which is non-structural slab at ground level. That's called grade slab. Then it is RCC column works. After that is RCC wall works, and after this, next one is lift well works, RCC lift well works. And following this, you'll find RCC longitudinal staircase work. After that, I have RCC suspended slab works. Then we should have, after this too, I have not completed this yet. I'm just trying to move yourself on these lists, and that is structural steel frameworks, pedestal footings, and of course you can say such footings for structural steel frames or overhead gantry girders, and that is massive blocks or kind of some thick elements. And after that, we'll say about, you can say, DC generator and alternator foundations. You can say standby power stations, items. These are components. These are, after which is you can say this fair face structural works, and in RCC architectural finish works. After that is, you can say hoodie slab. You may say hoodie slab based work. Then you will find sloping portion floor slab works like stair cover. And then RCC general sloping portion suspended slab. It would be RCC heavy compressor foundation tabletop works. Then you can say in that all elements, and then below ground RCC swimming pool. We will say firing or shooting range, and after that is now pores start after this. I may add some more if I have, but all this after that pores of concrete. How to do pour? That's what's required, which is a very important item from our point of view, because the suspended works. We start with the suspended slab works. I had explained this up to few points yesterday, but light was a problem. There was some storm, so I will just read it and then we will move further on this. I will just read it points first, because I already explained. I will not explain more on some points that will come on. Says checklists for RCC suspended slab works. Thus, conduct in-depth coordination on drawings for relevant involved activities. Ensure that all IFC, AFC drawings are available, and you can say structural and coordinated services drawings are ready for construction reference. No works of service inserts. First fix items shall be allowed without being given IFC status to all services drawings. Actual details pertaining following settings should be charted out clearly for communication to site. For an error in incorrect information may mar site work. In suspended slab case, setting of all building controls, main axis, and columns and beams grids located in both directions are accurate within defined tolerable limits. All supporting system scaffolding drawings are ready, duly approved or certified by designer of manufacturers, vendors, third party, and of course can say all access temporary work provided. Routes to scaffolding details must be ready per safety requirements, duly approved by tagging indicators. All accessible stepping type ladders must be ready for use wherever required, duly approved by tagging indicators. Whatever supporting materials for all involved areas in scope of pour for safe working in and around pourable area must be checked to be available. Materials for all areas involved to be poured must be available for installing preparatory works. Ensure that all fabricated cut and bent reinforcing bars are ready or available, duly tagged. Ensure all column and RCC walls, if involved, have been poured. Ensure construction joints are prepared on column and walls tops. It requires proper scabbling or hacking to expose aggregates by removing latents. Ensure datum level lines are marked on columns surfaces. Ensure datum level lines are marked on RCC wall surfaces, and ensure erection of supporting either mechanical cup log type system or other propping system is well handled by specialists trained team of riggers. Ensure that erection or installation of involved system provides a good space to circulate within without causing any obstruction from construction as well as from complete safety viewpoint. Ensure fixing of all beams or bottoms of downstands are commenced with at right locations all over areas, which is an important activity and therefore must be ensured for correctness by land surveyor or an experienced foreman. Leveling of beam soffit is significant but should be within approximation at this stage, for it would be corrected by adjustment at final level check. Ensure that beam sides are able to be stripped out conveniently while beam soffit is in place, which soffit may be in place for defined duration of formwork strike. This requires that beam sides plates top lines should be erected up to points below slab soffit form level so that beams sides are not trapped in slab soffit, below slab soffit. Ensure slab soffit levels are correct and system is installed accordingly to meet design and construction requirement. Ensure safety railing equipped with all component is available, duly installed around working areas from smooth working and safety reasons. Ensure correct alignment is marked on slab exteriors for slab edges formwork. Ensure location of construction joint if so required for a major core. Ensure that grid locations from access lines are correctly transmitted. Slab beam lines. I'll be back and you can read these points further because these are important one. Up to 25 read and you can read further, and I'll be back in some minutes for I have to go. That's important one. So we can say now, we can say that I was on point 25. Yes, here it is 25. I am back again and we are just going to this. 25 point was ensure the grid locations from access lines are correctly transmitted on slab beam lines. Ensure that beam sides could be struck easily prior to slab soffit forms. Explanation already given. Then make sure correctness respecting slab profile. Make sure correctness respecting slab profile by checking levels on slab. Make sure correctness of dimensions of beam sections. Make sure, if so required, timber fillets, chamfers are fixed on beams corners for exposed faces. It is written timber fillets, but it was old. Now it is actually plastic fillet, to be very frank. Fillet is a triangular section. Fillet is a triangular section of belt. Fillet is a triangular section, right angle triangle section, no other. It is a right angle triangle section, bead type, made of plastic, and therefore should be available in market, which must be fixed on exposed corners of beams, not other corners. Exposed corners of beams and columns if design mandates it. This is also applicable from convenience viewpoint, because if suppose somebody stands at that column corner, this, without bead, there will be a sharp line and which will pinch into hand or in waist if you stand like that. But if it's beaded one, triangular fillet one, is one pinch that way, and of course it gives view also, better view. And make sure that foam strike agent oil applied and dried out prior to commencing placing reinforcing bars. Now ensure that reinforcing bars are centered and fixed to meet design's requirements. Beams reinforcing bars may be assembled on ground or in yard, and if so convenient, otherwise these bars could be on site location, assembled per design as well as site requirement. Ensure that all bars are tightly bound. And concrete or plastic spacers fixed uniformly. Ensure that all bars are tightly bound and concrete or plastic spacers fixed uniformly. Ensure that all services blockouts are marked. And fixed wherever shown. Ensure bottom reinforcement is placed as required. Ensure that electrical first fix conduit work is done satisfactorily per shop drawings and inspected by competent electrical engineer. This competent electrical engineer means consultant or your quality engineer, whoever is specialized in that. Ensure adequate overlaps are available for next continuing floor slab, if that being a requirement case. Ensure adequate overlaps are available for next continuing floor slab, if that being requirement case. All exposed bars not to be concreted must be protected from oxidation using proper cover sheet. Make sure that all overlaps or extending bars are well held by rings or straps. Make sure that all mechanical connectors or mechanical couplers, if used in place of overlaps, are well placed and fastened. Tightened well. Mechanical connectors or couplers assembly samples must be tested for tensile strength prior to use. Ensure that adequate space is available after mechanical connectors and couplers are included for convenient passage of vibrator needle through that column or beam. In case epoxy coated bars are included, ensure continuous application of activity of epoxy touch-up paint is conducted for surfaces or points that have been peeled off of epoxy paint. Make sure all previous concrete joints are well cleaned by scabbling, hacking. Ensure that no dirt and timber piece etc. is available. Ensure that no dirt and timber piece etc. is available after cleaning by air compressor is done. All such holes or small passages used to compress blowout dust must be closed. If it is hot weather condition, keep formwork cool by allowing water spraying. Every care is required to be taken to check that flash setting of concrete would be avoided. Flash setting causes deterioration, danger to concrete because temperature of steel plates or plywood in hot weather condition is normally higher, and steel reinforcing bars remain too hot to successfully receive concrete without heat or thermal impact. So we can say, every care is required to be taken to check that flash setting of concrete would be avoided. Flash setting causes deterioration, danger to concrete because temperature of steel plates or plywood in hot weather or normally is higher, and steel reinforcing bars remain too hot to successfully receive concrete without heat or thermal impact. Concrete required Concrete required material property is endangered. concrete required material property is endangered by such flash setting impact due to existing differences between concrete temperature and steel temperature, as well as due to plywood or steel plate temperature. Concrete required material property is endangered. Again, I say concrete required material property is endangered by such flash setting impact due to existing difference between concrete temperature and steel temperature, as well as due to plywood or steel plate temperature. Ensure that stair portion to be poured with slab is well scabbled at construction joint locations, and reinforcing bars are cleaned properly. Ensure cleaning of lift well slab portion, projecting reinforcing bars that have to be cast monolithically with slab concrete. Ensure all blockouts or inserts are in place for shop or working drawings. Make sure if so required, scaffolding system being sound and fit for intended purpose. Make sure that all portions of beam downstands are well secured by fixing tie bolts, which wherever required. If beam depth, for example, is more, say 45 or 50 mm, I think it's required. If it's 20 or 30, it's not that much important. Ensure that all column caps or necks forms are in plumb to previous concrete vertically and well secured. This top column portion shall be poured monolithically with beams and slabs. Generally, I see in structures that there's some kink at this location, which is wrong. When you measure plumb, you take plumb at neck at two locations at least vertically, and then you take plumb on previous concrete down, and if suppose there's a ply on top, you can say whatever value of plumb you get on previous concrete, add to that thickness of ply, and you can say, you'll find same value, right? Means plumb value at previous concrete equal to plumb value now plus ply thickness, it should be equal. Otherwise there is an error, you correct it. So what I say, that ensure that all column caps or neck forms are in plumb to previous concrete previous concrete's verticality and well secured. This top column portion shall be poured monolithically with beams and slabs. Ensure a thorough inspection is conducted for all preparatory as well as temporary works, with no doubts and no uncertainty should remain unattended. No uncertainty should remain unattended. Plan your pouring activity in all respects, defining locations of pumps and truck mixers. Make sure that certain formwork stop ends or strips for meeting certain emergency provision of construction joint is readily available. Make sure that reinforcing bars to be placed in steps of stairs are laid for design requirements. Make sure that reinforcing bars to be placed in steps are laid for design requirements. And vertical forms for risers erected in position, duly anchored by a long timber scantling or batten or lumber centrally located longitudinally parallel to waist, and all risers plates are connected or fixed to inclined vertical plates of waste on both ends prior to start of concrete pour. Timber scantling, or batten or lumber centrally located longitudinally must be strong enough so that workers may walk on it to move up and down without disturbing forms, and also work on horizontal treads, surfaces, wood finishing of concrete. It's wood finish or timber finish, you can say, not steel finish. Make sure that planning of concrete pour be conducted. Make sure that planning of concrete pour be conducted in a way to avoid possible cold joints that would certainly mar on harm or harm concrete properties at such cold joints. Cold joint is defined that leftover compacted wet concrete. Cold joint is defined that leftover compacted wet concrete portion that has been delayed for laying another layer of concrete to be placed on it without complying with limits of initial setting times of concrete. Cold joint is specifically rejected in structural pours, and therefore concrete pouring sequence must be defined accordingly and order for procurement made per plan of pour. Chart out concrete start timing per pour plan program. Chart out truck arrival sequences keeping abreast smaller quantity of ready mix concrete. Chart out truck arrival sequences keeping abreast bigger considerable quantity of RMC. Define concrete date to place RMC order. Define concrete date to place ready mix concrete order in depending on formal approval to pour. Define concrete duration. Duration may vary from start to end of pour. Define curing procedures. Could be combination of application of curing compound as well as use of water fogging spray followed by formal process of curing. Check all equipment availability. Vibrators, mason's tools, RMC equipment, curing pump or water tank, etc. Make sure that testing laboratory technicians would attend in time with all necessary instruments, equipment. Prior to concrete pour, check all supports and system again. Skilled carpenters and steel fixers must be available during pour to ensure supporting system remain intact and steel bars remain intact as well. Make sure that adequate workers strength from time to time during entire activity would be available during pour. This is very important because number of workers may change from hours to hours. Sometimes it is big pour, you need 2 or 3 groups of people. Sometimes it's very small pour, you have to read accordingly. Make sure that concrete pouring timings match with concrete temperature range being 5 degrees Celsius to 32 degrees Celsius, and you have to care about ambient temperature as well. Do not work in haste as work must be safely carried out. Make sure that the responsible supervising engineer would be available during pouring. In case there is already one slab below proposed system, ensure that additional supporting system is installed under existing lower hardened slab Depending on day of previous concrete pouring, once working safety is overlooked, site shall be prone to untoward accidents. Final checks must be conducted for all alignments, for all levels around whole areas, all peripheries, thickness profiles, concrete spacers, cleaning, watering and status position of steel chairs. Necessary temporary paths must be laid over for safe and smooth movement by workers without disturbing reinforcements. Reinforcing bars particular requirements. Ensure reinforcing bars are clean and free from rust. Ensure sacrificial anodes are fixed if so required, in which case non-epoxy coated bars shall be included. Ensure that electrical continuity check shall be conducted if cathodic protection mechanism is installed. Ensure touch-up paint is applied in case of epoxy coated reinforcing bars, and no cathodic protection is permitted on epoxy coated. This is brief explanation of slabs to be poured and applies to all slabs, not to one or not to two. Maybe let us see what's this sketch first of all. I want to see it's this is useful sketch I'm showing for purpose of scaffolding and for purpose of temporary routes. You can see this is that working platform it is. You can see this, and also I like to bring to your attention other one, and that is you can say can see, just for your reference I'm showing you a kind of slab. It can be anything, whatever you say, but just for reference, for nothing else. I'm showing to you what is that. For reference I'm talking of, and sketches sometimes work better than explanation. Let me see what is that. I don't know. That is hold on please. So okay, this is also right. This is also important one. So I'm showing you all, and it's important one, you can say. So in this statement, this is one. I show you this is sketch, and this other one. This is for temporary work, access to site at all levels, and connected to stairs, connect to something which won't allow movement of this temporary work, and this is resting on ground with plates and firm grounds, firm base, and it's the side of this. If you can see, you can go up to top one. So construction starts from here, and everywhere there is, wherever you go, this is like that. They don't show here, but it show is here. Wherever your work goes on, it should be provided. And this is clipping the anchoring of this at every level. This is scaffolding working platform, and after this is your plan of floor, plan of slab that you are going to pour. And you can say construction joints may be required whenever necessary. Maybe it's required here. You can say there's a breakdown. Suppose you are concreting from this side, there's a breakdown. You can say I can provide style like this, and it depends. It's not necessary. Wherever you, just the indication I'm giving you, it can be like this, like this, like this, like this, like this, and there should no concrete that side where your new concrete has to come. You have to clean everything there. Construction is very important item, and if you can say when your construction joint work is over, you have to do new concrete based on your specification. You can start You have to remove those shutters, those strips, and you can say scabble all joint. It may be vertical joint or it may be two verticals half off. You can say like this. Suppose it's like this and it's like this. Three sides, two vertical and one horizontal. You have to expose all aggregates on these three. Clean perfectly, and then you can work for next one. You have to, the overlaps of steels are not overlaps. I mean steels coming. You have to clean all steel, all cement material from that. All you have to use hardware brush and clean everything. Nothing should stay there. Not even a single particle of concrete. And that's what is a complete scabbling. No latent set latent should be there. And you have to clean all again and you have to make sure if something is damaged, you have to repair that for doing this. So construction joint definition and its actions are very important, and that's what it says. Now I'm just giving an example. You're going to pour this slab. It's not means very small, but the example is okay. So what it is, there are some bays here. You can say this is for bay here. You can say this is for scaffolding base support system, and these are beams here separately done. These beams are here separately done. And you can see these are beams. You can see this is system. These are to top support. Head, you can say proper is scaffolding head, and this is ground. From ground may be grade slab or it may be structural floor slab, and you can see system is there, and that system is there, maybe 1 meter by 2 meter or 1.2 by 2.4 meter, and 8 meter. Here I'm showing 8 meters. It can be whatever, and the beams are there. You can say beams, which means there's a your site support system here. Maybe plate, and below that is jack, or you can say this prop or stiffener are here. You can say because it's not very wide beam, so one support may do. And of course there are bolts here, tight bolts and battens and ply, same thing here. And on this you will find complete details of your formwork, maybe your ply, then you can say ply, and before on ply crosswise something you have standard lines, and then you can see this is slab system, slab support system, framing type, typical proprietary coupler we call it, coupler system, easing of working in that. And this is the sketch, and this is the sketch. So I now take some out of them, so that and I got my point right. And one more thing I'm saying, this is just here. If suppose I am going to do it this way, I have to plan on this, on whole work of this. I have to put these as rectangles or squares here, or maybe I start from end, and we keep on going to provide a whole, and also all up to all. And there is something left on us, like some small pieces should be done, or if don't have small pieces, then prop system you can do. Where suppose we stop here 1 meter, or 1 meter here we stop, or like this, one end must be complete, other end. So we have to use that plan which is shown here for this purpose, and this is just continued throughout. That's basic purpose of this. And so we can say now next one. I think I got my point right. My point getting is very important, rather than just I'll now again concentrate on this little more. But we discuss this is about slab, and because it is quality check, it's quality item, we should not leave anything undone. Everything should be practically done. Everything should be clear and perfect. Mind should be perfect, sequences should be perfect, and that is beauty of professional work. Nothing should be left to time. Nothing should be left to automatic work. Means we have to take care. Means that's what I said. Site work is also structural work. It is not sitting in desk and working. You have to move on and on. You have to be a mobile site engineer. You have to be a mobile project engineer or leader. And this means you should be busy all time. One planning is on schedule, bar chart, and other planning is in your mind, in engineer's mind, because schedule also prepared by you, but during preparation time all factors you might not have procured or imported into your mind. But now you are working, day-to-day difficulties, how batching plant supplies material in scheduled time or no, and all problems you face. Means you have to think on every issue, of course momentarily, to find solution. For example, your pump is able to reach on all areas of your floor except some areas. Let us say it doesn't reach to 1 or 2 meters of your scope of concrete. So what you do? Shall you pull concrete? No, you can't pull concrete. And you cannot even move it through your, you can say, shovel or hand shovel. You can't even move that way. It's not permissible because it will segregate, and this is not game. So what you have to do in that case? You have to say 2 meters are left in square, 2-3 squares, and you have to do, and you can't change position of pump immediately. It takes time, and the transit makes its weight. You are emptying the concrete. So you must have some wheelbarrows, and you must have some path to move them on. And those wheelbarrows are filled up manually or otherwise, and you transfer concrete that small portion. And these points you have to keep in mind. You also keep in mind that when concrete is done, vibrator application must be done. Sometimes in enthusiasm you may forget, people may forget, but one person should be there all the time, supervisor level or otherwise charge hand level, or vibrator person itself, if that person is pragmatic, to make sure that application of vibration is done, is effective. Because even say sometime it is forgotten, it's forgotten, and they don't care and say okay, no problem, it will take automatically. No, it doesn't take automatically. Vibration is a must. Every time you should be behind, like police arrests or follows of a thief. You have to be careful about that. No concrete should be left without compaction until it is self-leveling. And whatever slump you have, higher slumps, slump is very good, doesn't matter. No, it matters. You have to get 2400 kilogram per cubic meter density. And if you don't get it, your concrete work in that particular portion where you forgot to vibrate is void. But it will be very difficult to know until you take cubes of that and test them. So it's very important one. And other important idea is how to do it. Means we'll see in pouring time, in pouring method. It's now the preparatory method I'm talking here. Just an example I give how to do that. Just a practical method I'm saying. We have to be very careful about lines, about axis, about grids. Never use grids for confirming measurements, believe me. Always take measurements from axis lines. Surveyors may be there, they can do it, no problem. And they are not there, means then you are only person there, or you have to train someone. Axis reference are more important than grid references. There may be 10 grids, for example, in one x and one x-axis or y-axis, 10 other one or some other. What happens, suppose there's error, if you take from grid to grid, you say, drawing is like that, I'm going to take, that doesn't matter because I'm following drawing. Yes, you are following drawing, that's okay. But suppose there is a difference of 5 mm in one grid, then there is maybe another difference of 5 mm, other one. So it goes on accumulating, say you got 10 grids and there may be 50 mm difference, 40 mm difference. You may not notice because you are measuring from grid to grid and you're okay. But if you take overall dimension, it will vary. It will vary, and you say, why it has gone up? I violated that dimension. That's what I'm saying. Always have your XY grid, X-axis grid and Y-axis grid of plan be laid and fixed, even if it's not mentioned in your drawing. And then you can say from this grid, from this axis, what is my grid length? You take from that axis every grid and establish. If suppose there is an error of some millimeter in one, it shall remain only in one. It shall not accumulate on all grids. It's a very important point you have to keep in mind. And therefore, what I said, that's an important point for measurement. It may be beam sides or beam axis. Better you take measurements up to axis of beam, or you say where grid is, you can take from there as well up to grid main, and from there you go this way and that way. It applies to columns, it applies to beams, and levels apply to verticality. Means these are major you can say major requirements for sizes, for dimensions, and other requirements for supports. Like once you have inspected and when you made sure that location of these columns at top and bottom of each column is fine, I made sure. But you have also made sure that what's about middle space column, and same thing I made sure of beams. They will make sure of beams also. All these difficult types I said. You may say that I have done it or I have done that. That's not enough. Means you have to do it. You have to do it. Means you have to do it. Put my switch on. Otherwise it will go away. So my point of view is that whatever we do on site, as part of requirement, we have to be very sure. Every point is important. Don't be in hurry. Measurements, dimensions, levels are very important, because if these are missed, if these are not to drawings, not to requirements, not to dimensions, levels are not correct, you will find big problem in future as far as corrective measures are concerned. Or you may say, if NCRs are issued, non-compliance reporting is issued for that work, it's very difficult to correct it. Be careful, because once a structure is done, there is no way it can be changed, it can be modified. Yes, honeycombing is there. There are ways to deal with that, but dimensions, locations can't be changed. And it's very important at time of setting out, at time of inspection of your members, inspection of slab, and before slab, inspections of your columns and others. What we do in effect, actually, quality system says that you have to do pre-check, pre-work check. I mean to say, before concrete, this is a check on concrete, this is inspection of concrete. Pouring of that, you have to check all sizes, everything, plumb and that before pouring. And I have explained already how to provide string from grid of columns or beams about 1 meter, and then see dimensions from that, how much should be, like calculations, what it should be. That's very important point we should not miss. But it takes time, of course, I know, but you should have patience for that. It's better to use some time, maybe 2-3 hours, 4 hours on that complete check, rather than repenting when work is done in incorrect location and everybody has to suffer because of bad quality of controls, bad quality of horizontal and vertical controls. I call it horizontal control and vertical control. And you cannot then bring maybe your plumb is okay, fine, I have measured plumb, it's fine, it will be fine, even if location is disoriented. No, if your column is twisted, but you will find plumb is okay, but that doesn't mean it's in plumb measures only verticality. It doesn't measure orientation, it doesn't measure line work, size work. Same way plumb, but that line which I'm telling you, line that is set off say 1 meter or more depending on your size of column, and from both grids of column you do that. And if column size is more, let us say, you just take horizontal measurement of from column to your this thread of the line I said, and you calculate how much it should be. You can easily calculate, because suppose you measure there's axis of column from which it is one, you can say it is grid of column, it is 1 meter, your thread, that's 1000 mm, and maybe your column is 40 or 400 mm, and your grid is in middle of column, so 200 mm is half. and then you can say 200 mm, you can add 20 mm or 18 mm, whatever you have for plywood. So we can say 200 plus 20, 220, and maybe you may measure up to ply, or you may measure up to timber piece. It depends. If you measure up to ply from string, then you can say, if you have a chance, you can measure. I'm saying that if you can measure, then you can say 20, 220, and 1000 minus 220, it should be 780. Same way, suppose there is a plank also, so there's a batten also coming, so it may be 50 mm or 75 mm. You can deduct that also, and you get this my measurement of plumb. So it's okay. I'm sorry, not plumb, this your layout, and that should be done at top as well as bottom in both directions. And once you do it in top and bottom, and of course you are sure that my top and bottom are set right, you can check in the middle also by that method. Or of course when you take plumb in all these three positions or four positions vertically in both directions, you will find setting out is okay. But if you want to make sure additional one, you can take that measurement at middle also. But I think it depends on your practice, how you do on site. It's a method how you can satisfy yourself, and you can satisfy your seniors, or you can satisfy consultants, or means once you establish your capacity of proving or working that you work under controls, it's fine, everybody trust you. And this is one part of theory, one part of practice on site. The pre-concrete controls which quality guy also do, and other one is post-concrete controls that generally is not done everywhere except on industrial projects because of their heavy nature. Controls are done, but those controls are limited to levels and not to dimensions. That's a very important point. Here we are not just talking of levels, we are talking of levels as well as dimensions, or you can say measurements, or locations, orientations, you can say. So whatever you do pre-concrete, you can do post-concrete also, so that you are sure, 100% sure my work is okay. And certainly, yes, there will be some difference, some post-core also due to some minor bulging, or you can say plumb is out somewhere. You have to check that, record that, and then think of how to apply correction to them. Of course, surface behavior shall be known. It's good surface or not surface at time when you go and inspect. But controls, I'm talking about location of sections and columns and beams, in particular right position. You have to make sure, because and what happens sometimes, it's not necessary every building is residential. You may have some building with industry, some factory, or something has to go besides column. There may be some pipeline or some other, and if your orientation doesn't allow it, and then how can you think that your pipe shall pass? You have to be very much sure about that. Generally, you may say that RCS is such an element which can create whatever you want, which can produce whatever you want. So what I would suggest, in addition to pre-concrete check, post-concrete check must be done. And once you feel that we are in controls, this check, post-concrete check, will not take much time. Your eyes would tell that there's something wrong here. And also controls on slabs, as we talked of recently, and also there are additional notes, and we may do that. So therefore it's an important point we have to do. So slab is very much important element, component of structure, because without slab, your suspended slab, you cannot say work is to some extent seen over, and next floor will start only if your suspended slab is done. Next story work will start only when this slab is done. And it's not only slab is done, we have not done it in this talk, we have done only preparatory works which are very important, and we have to make sure that steel which is going to be hidden from view in future should be in right position, spacer blocks, and you can say all conduits, pipes. There should be no failure in steel reinforcement locations. There should be no movement, and there should be no rusting in that. We talked yesterday, we just put some Rusting is not at all permissible. First of all, it should not be allowed, and by chance if it is allowed, it has to be removed by whatever method you do, by sandblasting. I think that's best method. Or if you have very little rusting here and there, in that case you can use hard brush also, depending on requirement. So this preparatory works of electrical and the steel placement, we have to see that no steel is down, and below the steel there are adequate number of concrete spacers or covers. It may be plastic covers or prefabricated covers. It should be there, must be there. We have to keep that point in mind. And if we don't do that, means we don't do justice to ourselves. We follow wrong procedure, we follow something wrong. That point we have to keep in mind, and it's very important one that we be perfect about that. So I'll put these sketches off now because purpose of sketch is over. I'll talk in general and some other item. And just give me 2 minutes, I'll open my main door so that I'm going to talk to you about framing, structural framing. So I was talking about slab preparatory works. So we have covered columns work, we have covered beam work, we have covered scaffolding system, we have covered access routes, and we have covered preparatory works of so many items. And I know there is no end of these items, but it is also important to do as much as possible. And those people who are getting this information, of course, are lucky, because in our time we did not have any such reference, any such, you can say, referrals. And if you get that, I understand that for them it will be a problem, because I'm sure that in examinations these items do not value anything. If you see syllabus, construction systems which are given are very much elementary in our syllabuses. Elementary to a sense that you should understand only, nothing else. Practical aspects are not covered, and that's really unfortunate. Means when you are an engineer, you come out of university, you should know what work you have to do. But if you don't know that, means you have to learn for a couple of years, and that's required. Means if you don't work for 4 or 5 years, with concentration and the opportunity for that as well, you can't do independent work. This is status today, not only here, everywhere. Means you have to learn. Means in university you learn theory of structures, your basics of construction. You study science of soil mechanics. You also study so much there. You study surveying. Surveying is of course very important, and you study applied mechanics, strength of materials. All those are very important. But syllabus that applies to sites, that applies to work, I think none of your degrees, even up to doctoral level, want to equip you with that power to work. And that you have to earn yourself. Nobody will teach you. You keep your degrees with you, forget them for a couple of years. If you keep them in mind that I am MTech, I am BTech, I am PhD, I am this and that, believe me, you won't be able to do site work. Because this is like narcotic. You keep, I have this much degree, and this engineer, senior person is asking me for excavation. That point comes in mind. I have experience about this. People talk like this. I met in 1981 when I was in Iraq, Baghdad. One project was Amsaid. I think not Amsaid, the Sad 3 project, army-based project. This person, I was young, but this person was very senior from Maharashtra, and he was incapable of doing something. Maybe he was in government superintending engineer that time, and nature of work of superintending engineer, he doesn't know anything about site. In his superintending engineer era, they go to sites only for purpose of visits and come back. Then involved in deep in-depth study of work, and maybe others do same, I'm not sure. So this man, it was a contracting company, and this person was asked every day in meeting what you have done, what you have not done, and he used to say, I've sent slip to that engineer, I've sent slip to that, I've sent slip to that, and arranged for excavate, and there's this, nothing happened. I had an opportunity to talk to him, and I said, what's the problem after all? Every day you say this. This is what I do. Means they don't respond. They don't respond. Who don't respond? These people, I give them slips, and what can I do? Tell me. I ask him, see, you are a very experienced person, and he was experienced, of course, superintending engineer. I told him, it's different world. It's not our India, our Bharat. It's practical world. It's not authority world. Here, engineering means engineering. It doesn't bureaucracy. These people don't require bureaucracy. Here, engineer means you have to deliver, and that's it. So what do you mean? I mean, slips won't work. You are a slip. You are given a project. Now you have to start excavation. You arrange excavation. You be called setting out. First you have to do, and then excavation. So what should I do? You have to arrange everything. Oh, see, I can't do that. I can't stand on site like this. I'm not used to that. Oh my God, better I should leave this job. Well, I said, that's up to you. But if you sit in office all day and send 10 slips to people and none slip works, and they will laugh on you. I mean to say, I'm not backbiting that engineer. His conception was with government work. He experienced some government activities. But even in government, in Gulf countries, in Middle East countries, that's not situation. I've seen different attitude. So this person unfortunately left that job because he said, my job in Maharashtra is safe. I'll go back and pick my job again. I did not leave that job. This is what I'm saying. Sometimes we have to be different. World is not India. World is not Bharat. In engineering, if you want to do quality work, if you want to achieve targets, objectives, you have to involve yourself. There is no other involvement. You have to teach yourself. You have to learn from yourself. Your experience will teach you, and your conception will lead you. That is best point only. Nobody can teach anybody in engineering. Yes, interactions do work, but interactions with whom? Interactions with whom you do. Experienced persons are experienced on non-compliances. How can you interact with them? Designs persons are experienced on designs, and there's no meaning to interact with them with construction activities because they don't have any basis of that. If you see some planning engineer, planning I mean to say bar, this planner or schedule engineer, if that engineer is not experienced on real construction, there is no meaning of interaction with it because that person will not suggest, that person would say itself. I just, there was one planning engineer in same project I'm referring to in Iraq. He used to do planning and was like, oh, this date you go to site, this date you setting out, this date you call excavator person to order. My God, I said, what is your writing? You will tell me when call excavator. I can call excavator myself. I don't need your instruction or your suggestion. You just tell me dates from this date to that date that excavator requires, and that's it. And you do not simply give dates. You ensure this is correct. If you cannot do yourself, you sit with person concerned and decide. What I'm saying is, it's not simply bar chart dating. That is planning. Planning must have a construction basis, experience of construction, output of construction, and mind would tell you from your past experience, I did there on that site, which results were successful, so I can also apply here. Means, if you think your books will work, then forget it. There are no books available. Experience is book. Means you have to understand reality. Means without experience of sites, you cannot be a good planner, you cannot be a good quality engineer, you cannot be a good designer, and in fact you cannot be a good engineer. Even quantities require site experience in many cases. So I'm not saying because I have been sites, I have been multiple, you can say multiple subdiscipline worker. I don't call myself engineer, but I call myself performer. It doesn't matter to me if I have to work with design. Of course, I'm not designer, I'm not software engineer of designs. I cannot argue to that extent as others do, but grossly you can say, I can tell, I can have vision of what should be constructed, and that is vision that is important based on requirements, based on architectural detailing. Vision is very important. If you don't have vision of stability of structure, you can never design it. Whatever you have to design, you must have total understanding of that. Yes, details are there. Details can be done by anybody, checked by anybody, but we have to construct what we have to do. Even in structural detailing, that's also important. What this structure should look like, because whatever structure look like, architecture will look like accordingly, based on your structural mechanism. So it's called mechanism, which means machine design. My structure, your structure, whatever you do is mechanism. It is called structural formation mechanism, which acts in unison of each other. All components work together. They cannot work separately, and that's not possible. And that's beauty of structure, that it moves together. And it still continues to work even if it's not properly done, till it can. Therefore, we have to consider many parts, many issues. I also understand that every work cannot be done by one engineer. We need coordinating engineers, we need coordinating staff who can understand what is saying. So I say that site engineering is quite a different field, which engineering cannot be learned from our institutions of education. We have to be careful about that. This point is very much convincing and important. I think we must be realizing this point. We cannot leave everything to ourselves. It has to be decided by various approaches. It has to be decided by various considerations. So purpose of this deliberation is to let people know, particularly young engineers, to know that they are still incomplete and just thinking that design engineer I want to be. That's your own outlook, because you don't want to stand in sun, you don't want to stand in wind, you want to sit in office on software and want to work. Normal life you want to live, because when you are in designs you need not go to desert, you need not go to forests, you sit in office and design, stay with your family. If that is your destiny, okay. But don't forget, design engineers are thousands worldwide. In India itself, Bharat itself, there are thousands and thousands, because this design time is different. Workload in design, 70% work is automatic. You have just to think on and feed, and that's it. And if you know software, how to run, how to use, it's not difficult. Drawings are also produced, and even nowadays quantification to some extent is done. So you can never be clear about problems involved in construction, and you will be, you can say, underconfident engineer forever. Underconfidence. I have seen that those who design, they always raise questions. I have reached this stage in this software, this gave me this result, I wanted that, what to do. Means you are not even clear of this. But if you have, I think decision making by design engineers is very difficult. I consider that designer best who has few years experience of site. That's a must. Otherwise, you are imaginary designer. I still remember one instance which is very, very mild. It was Libya. It was Sirte, town of Sirte. I had site there. I was in charge of that standby power station, and it was 1983. I was still very young that time, but I was project engineer. Then one visitor, our chief engineer, came there. He had three MTech, and he was quite smart. Once he called me in office, also head office, and asked me what type of work you are doing. It's machine foundation, there are such type of foundation, there is one such type of foundation, one is spring we place, somewhere place this. Means what is type you are doing, and explain to him. Once he was on site, visits that office 300 kilometers, and then he was standing outside, I'm standing outside, just interacting with each other. He says, sand, where is sand? Which sand you are using? Sand was there. It was in his eyes, He was standing at sand itself. Sand mound itself. It was sand was lying, and I was really surprised. Where is sand? Well, I'm not saying that he did not know. Maybe mentally he was somewhere else, and that was his point. That's what I say. His experience. I just asked him that I also want to do ME. Oh, don't ME, he says in Hindi language. Yeah, now he says something unpleasant, and of course I never did that, because I did not find that opportunity in my career. Of course I repent for that, but I'm not upset, because I did not have any MTech, but I am having good experience in construction, and that is more than MTech or doctorate, because you go on learning. Of course you won't get any academical certificate on that, but confidence is important. If you are a very good designer, You have plenty qualification, you have doctor, but if you lack in confidence, then you are no use. You can't work, you can't lead. Means you are a teacher. Teacher who teaches students. If you ask a teacher, even if you ask IIT professor or very experienced teacher, okay, take responsibility of this project. Do it. I am sure no one will accept that. No one. It happens. You know, whose line it is. Your line is teaching, your line is research, okay, do that. That's also very important. If you don't teach, students can't be engineer. So we cannot say that your work I can do successfully and my work you can do. Work is work. It demands devotion, determination, dedication, commitment. All these characters are required. And that is, you can say, root of stability. You have to understand it. That's where I say quality matters. Quality matters there. That's what I say. My approach on quality is that different. Your approach may not meet my approach because your quality definition only is quality control. My quality definition is not quality control, it is quality system. It is quality system. If you are complied with system, which is your system, it's not imported one, nobody imposed on you. You adopted yourself, you defined yourself, you designed yourself, and you are applying yourself. When all you are doing yourself, what third party will decide? Third party, this is, you can say, agencies of ISO 9000 and others, they only accept what you say. They never force you to do. Yes, there are some guidelines, there are some policies, there are some directions. You have to follow them. And then you have to bring yourself in quality system. So I'm saying, it is not easy. You want to standardize your quality system, you have to learn everything in that system. What are principles? What are policies we should have? How can we adopt that? What is our business, our profession? How we can move in that? How this not endanger us? Like that we can do. Therefore say quality required everywhere, and in engineering it is a must. What must it is, you know yourself. Then it's of course say systems quality, individual quality, product or element quality, attitude quality, dedication quality, commitment quality, and other parameters quality. These are summed up. It's very important. Summed up. And designs I discussed already, reasonable construction, etc. That's why only reason I want to use this file often, to just let you know what life it is. This is important projection of thinking and application. Without thinking, without application, you cannot do anything. Thinking is required for analysis. Thinking is required for synthesis. Thinking is required for thinking itself. And thinking is required for contemplation or contemporary work. And applications, of course. Engineering requires application. Engineering is affected by applications, and non-conformity is never accepted. If you have done non-compliance, means you are a careless one, ignorant one, incompetent one, and therefore redundant person. Engineering doesn't need you. You may be in engineering, that's different, but engineering doesn't need you. That's what I say. And it has a meaning that engineering doesn't need you. Whom engineering needs? Engineering needs sacrifice. I have seen many people, well, it's their personal choice. After doing engineering degree, they don't want to stay in engineering. Maybe reasons only they can tell, but I think it is a hard life. They don't live in engineering. They want They get through also. They want, you know, piece of paper. We have to understand all these points now before going further on this. Say, next item is pedestal footings for structural steel framework. The structural steel frameworks means, the sheds we construct, the industrial sheds or other sheds. You may construct in RCC also, but generally steel is preferred for that. Not stainless steel, structural steel, rolled sections, or you can say cold twisted, all that. There are different sections. They are designed by structural engineers. These are installed on sites, but how they are installed and who supports them, that's the point. You see, this structural framing generally is not multi-storied or 2 or 3 stories, single stories. Of course, height is more. It may be workshop, it may be industrial factory, or it may be whatever else. There are columns, steel columns and beams, or inclined beams, you can say, in single category cases, and you have to produce certain beam for these are structural steel members, but footing where these rest are connected by bolts or even engraved within, embedded within that. In embedded cases also some cases, but generally including AnnexSL embedded. These are small foundations, cubicle type. I mean to say, not exactly what we do in our way. These are sizes of these columns are convenient, and also you can say these are grooved in or bolted in, and these footings do not have conventional type of reinforcement, but commended reinforcement on all sides. I'll now discuss about this case reinforcement and preparatory works for such footing. It's called RCC, pedestal footing. You may pedestal, I just give a name, not necessarily a foundation, you can say. Footing for structural steel frames work is simple item, small item. I have no sketch for this for time being. If I'll show you later on. It is in my book actually, which I can't show you now. Now it says that used term pedestal for approximate cubical size of footing, approximate, not exactly, cubical size of footing. Use term pedestal for approximate cubical size of footing. Ensure setting out on blinding concrete is correct, or to whatever you can say, as we said in last items, your setting out on blinding concrete is correct. Ensure reinforcement in form of case is rightly fabricated in all directions. Ensure concrete covers or spacers are provided to meet functional requirements. Ensure void or pocket for anchor bolts portion is provided within top of cage for purpose of future grouting. Once bolt plate is placed on pocket or voids, ensure pocket or blockout for groove is fabricated correct to truncated dimensions. In case anchor bolt plate assembly needs be provided at time of concreting, blockout for groove shall not be required. If you use plates and bolts during casting, means then you don't need this truncated cone or something, truncated formwork. Have formwork erected to required dimensions on all sides. This is of one part. Also, you can say have it well secured and supported, and then have reinforcing bars cased place in. You have to bring this cage from yard, steel yard, and just hang and put on in your formwork. Or also you can put before and then do formwork. There's no major problem. It depends how safe you are. Have reinforcing bars cased placed in. Formwork plates can also be erected after reinforcing bars case is placed in. Ensure pocket blockout placed by approved supports is supposed to hang within pad volume. Ensure pocket or blockout placed by approved supports to hang within pad volume. When you use blockouts, these forms balls hang within volume, pad volume from top, and anchor them properly so that these do not move. Movement is also not accepted. You can say check building formwork plates can also be erected after reinforcing bars case is placed in. Ensure pocket blockout placed by approved supports to hang within pad volume. Check building axis. Check building axis and grids. Building axis and grids and grid measurement. Check dimension of formworks. Check top of concrete levels. Fixing arrangement. And then noting is reinforcing bars, particular requirements as usual. Ensure reinforcing bars are clean and free from rust. Ensure sacrificial anode or boss is fixed. If so required, in which case non-epoxy coated bars shall be included. Ensure that electrical continuity check shall be conducted if cathodic protection is required. Ensure touch-up paint is applied in cases of epoxy coated reinforcing bars, and no cathodic protection is required. Then we can say ensure reinforcing bars are clean and free from rust. That's one requirement, very important requirement. No rust should be available on steel bars. That's very important. Ensure sacrificial anode and boss is fixed if so required, in which case non-epoxy coated bars shall be included. Ensure that electrical continuity check or test be conducted if cathodic protection is required. Ensure touch-up paint is applied in case epoxy-coated reinforcing bars, and no cathodic protection is permitted on epoxy-coated bars. This is very brief actually. We got job of that was interested in that. This was item, so very small item, but there are so many items as such. You will find such items for corners of that shed generally, or some extensions, because where girders, heavy girders are to be installed for EOT, or you can say electrical operated crane, EOC or EOT as they electrical operated crane, or EOT we all call it, EOC. This moves in between columns of where crane is kept on top for handling material in factory or workshop. Such parts are used in non-girder areas or non-crane areas, means from gaviland of both. The main areas are used. This is called rock. Yes. Then next one about this is RCC footing blocks for structural steel frames and overhead gantry girders for EOT works. That was for corners, which I explained before, and this is for columns which carry gantry girders and gantries because of weight of gantries, vibration of gantries and all that. This is, you can say, big column or massive column, you can say massive column or massive lead bearing column. Means you can say the ultimate aim is that it should work properly. Now our point of view is not to just tell what should be done. My point of view is different. You have to think. I'm not saying what I'm writing you do that. No, don't do that. It's your choice. I'm just trying to give you hints, guide what way it should be done. You can do your way, but point is you have to be somewhere. If you learnt me or from somewhere else, you may say that yes, no. Then comes this one. I say now how it works. We have to see that. This point is also very important. Very important point. Now, well, I have again same problem of sketch of this. I sketch somewhere else. But no problem. My sketch is not big deal. I can make sometime else and show to you. But here is that for footing of long span steel frame for gantries, footings of long span steel frames for gantries, in plan it is rectangular shape with considerable depth of foundation block. Say in plan it is rectangular shape with considerable depth of foundation block. It is like say rectangular shape means this rectangle longer side should be parallel to girder or parallel to span of frame, not otherwise. And it is rectangular shape with considerable depth of foundation block. Ensure setting out on blinding is correct. Number one is ensure that setting out of blinding is correct. First is this, ensure setting out of blinding is correct. And also ensure reinforcement in form of cage is rightly fabricated in all directions. Ensure concrete covers spacious What is ensure setting out and lining is correct? Ensure reinforcement in the form of cage is rightly fabricated in all directions. Ensure concrete covers the spaces are provided to meet requirement. Ensure void or pocket for anchor bolts portion is provided within top of cage. This is actually very important. We say ensure void or pocket is provided. How many points are there? About 20 points. So, okay. Ensure wide pocket or grooves also we call them for anchor bolts. Portion is provided in top of cage, somewhere in middle, because generally it's middle one. We'll explain this later on. Now, ensure pocket block out for grooves is fabricated correct to truncated dimensions. This is pockets, blockouts for grooves. For grooves fabricated correct to dimensions, truncated dimensions. The curve is truncated. Okay, very well. In case anchor bolt plate assembly needs be provided at time of concreting, blockout for groove shall not be required. Have formwork erected to required dimension on all sides. Have it well secured and supported. Have reinforcing bars cage placed in. Formwork plates can also be erected after reinforcing bars cage is placed in. Ensure dowels for beams, if so required, are fixed. If so required, I said, may be required for plinth beams. Ensure pocket blockouts placed by approved supports to hang within footing block volume. This is a prefabricated one as said earlier. Check building axis and grids measurement as we said before. This is very important and it applies everywhere, not only in one case. This is a formula that we have to use grid controls as well as axis controls. Grid should be controlled by axis controls. Axis is prime controller. Grids are products. Axis is not product. Axis is controller. Reference, you can say. Check dimensions of formwork. Check alignment and plumb. Check alignment and plumb and check supports of forms. Check top of concrete levels, fixing arrangements. Then you can say check alignment and plumb, check dimensions, check supports of frame forms, check top of concrete levels, fixing arrangements, all, and if demanded, grade beams can also be provided monolithic depending upon design and your preference, or dowels can be provided for them. I don't think it will cause problem, or maybe it's also possible that those beams pass over footing levels. It depends on designs because it's industrial work. There can be so many issues depending on site conditions or design conditions, whether you have to do monolithic beams or you have to put your beams, dowels, and then do that. It's not a big deal. It depends on what structure you're going to do and how shall it react with others, interact with others. Just like it may be a kind of 5G, you may say. Reinforcing bars particular requirements, as usual we said before, that ensure reinforcing bars are clean and free from rust. No way rust can be allowed. Ensure sacrificial anode is fixed, if so required, in which case non-epoxy bars shall be included. Ensure that Electrical continuity check shall be conducted if cathodic protection is required. Ensure a touch of paint is applied in case of ensure the electrical continuity check shall be applied constructed if cathodic protection is required. Ensure touch of paint is applied in case of waxy coating. Now we'll take another list later on. This is RCC for DC gender, which is a long item, but this is also I can show something here. I don't know which I have here. Let me see if I can find something here by chance. If I'm just giving 2 minutes, if I see some drawing or something, I can show you, which is in interest of understanding of for future also, you can say, or future work, you can say. Yeah, sometimes cursor is a problem, you know. Okay. So I have to see what is that. Management documents, facilities on shore, sketches. If I see career photos, you can't see there. No, this is all. If I try to see if I can find that foundation somewhere. Column forms, couplog, RCC wall forms, sectional tank, CCBA energy shooting range, block concrete, mass block concrete sequence, hoodie blocks, house plans, slab basement, staircase, structure slab, tabletop turbines. I like to see some block immediately for your reference. Only we'll talk later on. Let's see first what is that. It's a JPG file. Let's not use hoodie block is JSL file. I wanted to see hoodie block actually. Let us see hoodie slab. Let's see hoodie slab first of all. This is your printout, and I'll say so you can see this is hoodie slab. This is your hoodie slab, I can say. This slab we'll discuss later on, but I'm just trying to show you. These are not, these are not foam actually. You can see these are blocks. These are blocks, concrete blocks, hollow block, of varying dimensions block, and you can see this is also between blocks. This beam is running. And this beam is running here, and many beams are running here and here. Can we see? This is a different kind of, means it's quite thick. This is called hoodoo, and I will show you here what's hoodie slab. That's also important. You can see this is hoodie. You may not see it, but let me print it so that you can see that. I could not find. I don't know why I didn't find it. Let me close it. Let us see why I didn't find it. File print. Print the PDF. It should be print. Why is not printing? What's the reason? It's not printing. Why? Why is not printing? Print. And 7. Of this, so it's not printing. Another process, which is that process, because what process is there? It is same process there. There's no such. How do we process? Let me close it first. Okay. Picture manager. How I can do it? File save as, save as. File save as JPG file. No, PDF file. No, it's not. Let me close this first. Can I print it? Some error. It's giving some error. I can't print it. I don't know how I got other one. I can't got this one. Let me close it then. Okay, this is what you can see. Other file, maybe there's some problem in that. I'm not able to print that. So there's some reason. I wanted to show you that block. I can't show that side. I want to show this block actually. There's a problem in this. I don't know how it got in. How it's not getting in. Yes, I failed here, in this case I have failed. No problem, I'll show you later on. It's important, but if something doesn't work, what to do? If something doesn't work, what to do? What is the point here? Oh my god, light has gone. Again gone. Light is a problem. Every time it's a problem here. Twenty times it has gone since yesterday. Tabletop sketch, tabletop sketch. I'll also do tabletop sketch. Let me show you this tabletop sketch also. It's also important. Rank or holding blocks. Okay, I'll show you this. Okay, I'll show another one. Alright, something is better than nothing. This is that holding block. You can see this block. This is that one. You can see there's a basis here and there's a basis inside as well, and this is bottom one to place him, on ply, and above one is upper one. You can see that. This is you can say cellular type cells. This is bottom one and this is upper one. Woody blocks are also called filler blocks. It's even they are used as infill in construction of concrete floors or roof slabs, ribbed slabs, to make slabs hollow, which improves thermal and acoustic properties between floors. 40 blocks are first resistant, fire resistant, and as well as resistant to weathering. These blocks, which boost sound and heat insulation capabilities, are produced in all standard shapes and sizes. Filler blocks of higher strength than those second. Technical details can be produced as well. So this we'll discuss later on. I'll put it back on this. This also I close now. I'll take, let me see, times over. I think it's already 3 minutes. So let me see one more here, and that is tabletop photo. I'll show you now. We will discuss later on. This is photo here, tabletop. We'll also discuss in coming time tabletop. This is tabletop. You can see this is machine here. Kept in that meter for generator. What's the diagram? What's written on that? And here is slab, top slab. This is top slab. And these are columns below. You can see these are columns below. Thick columns, and below these columns, which is not seen in, that is foundation, massive block. Hence this is salt. This for reference I tried to show you, and I can show you also sketch if you wish. You can see this as a sketch, tabletop, columns, and then foundations as well. This is not properly not seen actually. This is depth of foundation here. This columns and this tabletop. This is, we'll discuss this later on. And these are blockouts here. You can see this blockouts here and all that. It's quite thick, 150 mm here. This is let's say opening 1, opening 2. This is a plan here. This is tabletop, and this is 2.6 meter. You can see quite thick here. 2.6 meter. You imagine this 9.25 meter, and bottom is 3 meters something, and this 12 meter width. So this is called heavy structure. It's called heavy structure. We'll discuss with this later on. Now I like to close this for time being, because it's time over. It's already 3 hours. I will say thank you very much, gentlemen. I close this. Bye bye. Okay.